Can I start? Okay. My name is Roland Sonnenschein. I'm from Germany. And I want to speak about Postgres in real-world production. That is what I am doing. And now I have a technical problem. Oh, sorry. Really wrong. Oh no. Sorry, I will
maybe we can.
I will do it this way. So, sorry. So now I will do it from this way. That's also okay. So where I'm from Germany. I'm located near Frankfurt, not far away. And what are we doing? We are doing documentation of technical processes. So this is the job. So the question is, what that? Has anybody an idea what is inside this box? What that is for?
Nobody knows how to say this is in English.
It's in English. It's for bearings. That's a type. That is what is made. I can give it to you. And nobody would be here without these types of material. That is a bearing which makes everything which is rotating is based on this type of bearings. So, but first of all, I have to say these are our customers. Metaldyne, it's a big company. That is what they are producing, all things inside the car. That is one type of car. Can give it around. So, that's a job, but where's Sloney? Has anybody an idea what can be done with that and Postgres?
You are sorting these items in Postgres.
Sorting?
No, you put every item ID to the Postgres and sort.
In principle, yes. But in order to produce this type of bearings, that had to be heat processed. And what we have to do is to document the annealing process. The lot, what have to be produced is a lot of these boxes, and all this stuff is put together into cages and then put through a furnace. And that is what I want to explain, what that has to do with Postgres. So, what we have to do is, what we used SQL, we used arrays very extensively, triggers, JSON, JSONB, XML and XML path, timestamp of time zone range, PGSQL, and PLV8. So it is a good mixture of a lot of things. But that is not enough. You have to know. You also have to have other skills. You have to have program skills. You have to know about web, what is HTML5 to program it, and I will show it. CSS, JavaScript, SVG, scalable vector graphics. You know to know what a PLC is and how it works. A PLC, I will explain it a little bit later on, is a computer which controls such a big furnace. And you have to know about electrics, mechanics, processes, how to process things, and also have to know things about business administration, because that is what we have to do, the data we have to send to. So, and you have to mix this all fine together, and then you have the chance to do a good job. So, and now let's start to explain what is going on, starting with the chef. Oh, sorry. Sorry, that's like baking a cake. You start with the making the dough, the cake mixture, and then if you have done enough, you have to put it into cages. After that, put it into the furnace, and then there are two possibilities. Either my wife is baking the cake, it looks like that, or I am doing this, then it looks like that. So, the reason why I didn't do a good job, because I was very conscious, opened the door of the furnace, and then the temperature fall down immediately, and together with falling down the temperature, the cake was falling together. So, very bad thing. So, that is a so-called batch process. And what is important is the duration, how long the cake has to be baked, and the way how it is increase the heat and decrease the heat. That is very important. Not only for cakes, also for this stuff of bearings. So, if you want to do 10,000 per day, you cannot do a batch process. That's impossible. What you have to do is you have to to go to a continuous process. This is, you have a conveyor band here, put the cakes on this conveyor, and then transferring it through a very long furnace. And the furnace has different zones with different temperatures. And by driving the cake through this furnace, the furnace sees the temperature profile it needs to see. This makes things a little bit more complicated because you have more parameters, you have more different zones, you have different places, you have a velocity, and now you can imagine what is going on. So, but this is a process up to 200 degrees or something like that. Then you can use a conveyor band. But if you use a metal like that, it's up to temperatures up to 1,000 degrees. Then you cannot use any textile also. And that works in that way. It's a pushing thing. You have two cages, and the cages are pushed one after another. And I want to show that. So, here you see how this works. That is the way how the cages are put through the furnace. And you see a lot of different things here. These are, you have places, and you have cages. These are the number of the places, and you have cages which are put from one place to the next. And now you see, if you want to document all this, there are a lot of data. And that, you have a feeling that is where Postgres comes in. So, sorry for the... Here you see the different things we have to distinguish. We have a pusher, many pushers. That gives you the possibility to go around edges. You have indices of places inside the furnace, and you have tracks. These are like queues. And you have transfer regions. And so this is the way how it is done. And these are real photographs. Here you see a fork truck delivering the lot, the order. These consists of different boxes. These boxes are divided into cages. Each cage has to be measured by mass. And then the cage is put into a first buffer via a scale. And then inside the furnace there are two tracks. And then going to a cooling region, and then to an output buffer. And so that is the way it does. And that is a furnace who does the job. So you see that is real production, and it is really also a little bit dirty. So that is the scale where we have to measure the masses. There you see these are the pushers. This is the cage with the material inside. And I want to give you some numbers so that you can imagine what is going on. We have approximately 10 orders a day, or 10 lots. And each order can have up to 100 or more cages. And there's approximately 400 kilograms inside the cage. And there's approximately every 15 minutes one push. So it operates 365 days a year. That's the whole year, 24 hours. You cannot stop the furnace, it's impossible. So inside the furnace you have 71 places, 11 tracks, and 8 zones where you have to measure the temperature. Then what is also very important, you need process points. What you have to measure, we're measuring 250 process points and 170 alarms and events, which are generated by the systems, and all that is handled by Postgres. And Postgres is in the center of that all. So I want to sum up the job. First of all, we have to document the temperature of each zone. We are measuring all this temperature every second. So, and there are process values and set points, and they have to be compared. So we are in the furnace, there are 4 zones, and in the cooling there are 2 zones. And for each cage of each order, or lot, we have to measure the mass, we have to document when it occupied a zone and when it leaves the zone. And that is where the time range comes in. So we have to document all the alarms. This is if the temperature is too high or too low, or the pushing is too fast. There's also oxygen. Inside the furnace is oxygen free. Otherwise, it would not be look like that, so silver. It would look brown. And the residence time inside the zone has also to be measured and checked. Third thing is, you see, you have to merge it together. You measure the temperature of the zone, but what you are really interested in is to see the temperature the cage saw. That is a difference. So you have to merge or to fold it together. That is also done inside the database. Then you have to know how long has a cage been inside a zone. Otherwise, the cake will fall down. Problem. And for all this, you have to generate reports. about statistics, alarmings, and what is also very important, these data are coming from an ERP system. Do you know what an ERP system is? Okay. An ERP system is the business part of a company. For instance, SAP is an ERP system. And the orders are coming from the ERP system, and the ERP system wants to know what is this current status of the order. And with our system, it is possible to give an online view into the production. So, next thing is, and last but not least, all this has to be done via a browser, with internet technologies. In former times, this had been done on a PC standing beside the machine, but that is not state of the art. What they want to do is to check everything from the office, that everything goes perfectly. So, that is the schema, what is going on. You have the ERP system like SAP or Microsoft or from Oracle. There are lots of different of them. And they have, manage the customer, the quantity which has to be produced, and the quality that has to be produced, that is a spec, and the suppliers, where the material comes from, and all these things. But the primary key of this is the number of the order. That means inside our system, we only need the number of the order because that is the primary key. So then we have the material. The material which comes in has an order or a lot, because an order goes through different machines, and the lot is what is going through this machine. And the lot is divided into suborders. All that is done by a programmable logical controller. That is also a computer, but it is handled a little bit different than the standard computers we know. That is the database, Postgres. We have to manage the process. I described that. And we have to do the administration of all these things. And that is what I want to speak today. And what has to be done from the office is the planning, the current status, the temperatures online, the alarms, and doing the evaluation. And the other one, the business guys are doing the ERP system, and so it has to flow from this to that. So that is the former interface to the ERP system, a piece of paper. That is the order number, and the 15, that is the number of treatment, that is what is being done in this machine. So, and the starting idea, what was the starting idea? We have a machine with places, and we have a pusher pushing the cages through the machine on the different places. And this is mirrored inside the PLC in an array. That's nothing else than an array inside, an array of structs. And you see that is this situation, blue, green, red, the push, yellow, blue, green, and the red is outside. That is nothing else than inside the system, it's an array. So, and when we transfer this to the database, it is also very clever to remain this structure. So what we have an array of lot IDs, that's the name of the order. Then we have another array of sublot IDs, that means 1, 2, 3, 4, 5. That's exactly that. And then we have an array of sublot attributes, which is in our case the weight. Because there also can be other attributes, we used a JSON-B array for that, to be open. So you see, all this have the same structure: physics, control, and database. And what we are doing is Now that is one table, and each machine has one row in this table, and the only thing what we are doing is updating this in a cyclic period. After each push, we update it, nothing else. And all the rest is done inside the database. So, okay, how we started that simulation, that is, and that is what I want to say, is what is very important for me is that database structures should mirror the real physics. And so it enforces also the process logic, makes things much easier. So and now I want to show you a simulation, how we started. And sorry, now I have to show you my bag. Man. See anything? Yes. That is a simulation program. That is done in C#. And what you see here, these are the tracks. That is the scale. This is the first buffer. And then it's the transfer. These are the two tracks inside the furnace. And I will start it. Take some. And then you will see how it will generate a new subplot here. And now you will see how this goes through. You see now it is a cooling. And everything is pushed through the machine. So, and this data, there are two ways, and the data produced in this simulation is pushed into a simulated PLC, and then our system takes the data from the PLC and transfers it to Postgres into the occupation online table, and then we have to show what is going on in the machine. That is only simulation. And now I want to show you missed. Now what you can see is that is what the worker is seeing at the machine or also in the office, how things are going through the machine. So the way of information, simulation, real machine, PLC, Postgres, web service, browser. And what you see there, that is nothing else than a simple SVG graphics with some JavaScript inside. So I want to... So let's go on. So that is, for us, the Postgres is a perfect API. We use it as an API. So we only do an update when putting it into, and that is like a function, nothing else, where you have very complex parameters you can put in. And these are the parameters you put in. And it has an advantage that we have the old and the new data. And triggers inside the database do all the rest of the calculations. And the clients you just saw on the browser are doing nothing else than a select on the current occupancy. That's all. And that solves a lot of problems because this is always consistent. That is guaranteed by Postgres. It's transaction safe. And if you have multiple clients, no problem at all. It solves all our problems. So, and then the next thing is a description of the machine about tracks, places, and what all these things. This is done in a separate table with a config, and the config is done also with JSON. So that is are the names of the tracks, scale, buffer, transfer, ferns, 1, 2, and so on. The number of places, the type, a queue, or a buffer, or a transfer. I explained that. And then you have the next one. After that, the buffer comes. And after the buffer, transfer 1 comes. After transfer 1, furnace 1 and furnace 2 comes, and so on. So this is describing our machine, also in JSON, inside the database. And then we have to describe the zones. That is, in principle, for every zone, the name of the places, the number of the places which belong to this zone. So, and now let's go on. What does it trigger? If there is after a push, a new situation of the occupancy, first of all, we see, is this lot, the new lot, which is on the scale place, is it known inside the database? If not, I generate a new row in the lot table. So, and if so, that this belongs to a certain machine, that is the name of the lot, and then there's a status, and then we have two range types of time zones. That is, when did the first cage come into the machine, and when did the last cage coming into the machine, and then the same when going out. When did the first go out of the machine, and when did the last go out of the machine? And all these things can be done within this trigger. We use PGSQL for that. Now I would do it another way. And then if there's a new sublot, I also have to set up the sublot table. And this is generated all inside the database. Okay? So this is the complete database structure. It's not very complicated, but there are a lot of things inside, and I will explain this later on. So these are the status of a lot. And that is one type of summary we have to generate. You remember, for each heat zone, you have a set point. That's the velocity in this direction and the heat in that direction. And that is the variance of the heat. That is the variance of the velocity which is allowed. And the red rectangle is the allowed range. So that is a statistics over all the sublots inside a lot. And so within one view, everybody can see, had there been any cage which didn't support the specification. That is with one. And all this, that is also nothing other than a simple HTML file, where you give the sublot, and then the sublot is just asking to the database the JSON data, and the JSON data are filling up these things. I will show that similar things now immediately. Okay, that is, we'll skip that. And now I want to do a little bit more demo. 1 second, please. So, you remember that? And now, there's more information in. You see an event list, and now you can see, for instance, I'm interested in the red alarms for a certain time period. These are original data from the putting it into operation. And this is all what happened during the putting into operation. So now we want to have a look to the chart, what is going on. Let me see that. We want an online chart. And here, these are the simple, these are online data which have been produced by the simulator, but it is exactly the same as in the real machine. So you can check that. So, and there are some more things. These are a table of the current measurements, temperatures. We have no set points here. This is okay, and that is the next important point. That is the interface to the ERP system. So, and the worker at the machine has a list of what has to be done next. And if you are in the office, I will show that. Here, just in the beginning, you have the scheduled jobs. I make a new one. What's the name? Has anyone idea? Let's take my name. Roland, I apply that. And now you see the worker sees what he has to do next. Okay, then I want to show some more things. This is a list of the jobs which had been, the lots which had been completed. Let's have a look at this. And I want to see what is going on there. Let me save this with cage number 10. I open the diagram. And here you see what is going on. That is zone number 1, heat 2, 3, 4. That is the temperature. When it entered one cage, was in zone number 1. That is when it was in zone number 2, 3, 4. And what you see is it is much too long in zone number 2. That is because it is from putting into operation. Now here you can go through all the different cages. And what the system does in the background is just to ask in SQL the JSON data and displaying the JSON data here with the AJAX technology to a very fast reacting system. So every cage is documented, what was going on. So, so I'm almost ready. Let's go on. take the next one. I've explained that. These are the measurements. Yes, and we also use XML. That is used very intensively. So this is the XML file, which handles, you do not need all the measurement data, and this is also handled and stored inside the database. And if you want to access a certain channel, we always look with XPath into this file and get the information we need. So, and about that I spoke last year in St. Petersburg. So I mentioned the alarms and events, the online data, and the orders which are in the machine. Okay, and how to plan orders, and how to evaluate orders. Okay, spasibo za vнимание. And please excuse that not everything worked very well, but that's life.
Thanks for a great talk. What you are storing in PostgreSQL is basically what is called time series, and as I understood it. And my question is, could you please give some estimation of how much data do you have, and I mean gigabytes, terabytes, how many records, etc.?
Yes. Concerning the measurement, we can have terabyte database. That's not a problem.
I'm sorry, how many?
Terabyte.
Uh-huh.
Terabyte. In St. Petersburg, I've shown how to transfer 3 million measurements per second into Postgres with such simple programmer. So that is possible because we are using a hierarchical storage where the detailed data are stored in some type of arrays. So that can become a really big database. So any more questions? Everything was clear? Hopefully. So you see that is a little bit strange talk in this Postgres community, but that is what I'm doing with Postgres. Yeah?
Hello, thank you for your such interesting theme. And my question is, do you just collect this data, or maybe you are going to analyze some ways?
That is the first step of analyzing what we are doing.
Maybe you are going to make reports?
Yes, we are going to make reports, and we are also going to make very complicated evaluations. For instance, in the moment we have a project where we have to evaluate data for bearings of railways according to a certain norm. And that is the norm is thick like that. And we have to evaluate everything according to this norm. We are also doing that. But the basic is that you have a very good structured database where you can get all the data from. That is a separate module, evaluation.
Thank you.
You're welcome.
What is the name of your company?
Hesotech. Oh, and the name of the company is Hesotech. We have a small company, an engineering company, about eight persons working. And, but nevertheless, we do a lot of things, maybe even influenced you. For instance, you know Audi is a good car manufacturing, and that they have no problems with corrosion. That is partly our work. They have corrosion centers, and we did all the software to handle the corrosion center, for instance, and to do the evaluations on that and so on, for example.
One more question, a little one. You decided to use Postgres against other databases. Maybe some aspects you can tell us.
Yes, there are different reasons. I started using databases 30 years ago. And then we had a job for a power supplier to monitor transformers. And then we decided, okay, we also use a database. This was 24 years ago, about 20 years ago. At this time, Postgres wasn't existent in the way we could use it. And we started with Whatcom SQL first, and then have gone to Sybase Anywhere. And after that, that was what we have done with the Audi Corrosion Center in the first run. And after that, Postgres came with a Windows version. And then we switched by several reasons, because one reason is cost, and the other reason was the capabilities of Postgres. They are really good, and we are still they are still working 8.83 versions up to now. We have had no problems, no stability problems at all. And Postgres is a very stable system, and it's extensible, and it is also possible to run on these small machines. It is a wonderful system. It's very scalable, from very small up to a big data center. So, and this is a very big advantage for us.
What is the problem to upgrade Postgres to 9.4, 5, or 6?
8.3, 4, 5, or 6?
What's the problem to upgrade your Postgres from 8 to actual version? Or
Why? The system runs, and our customers say, why should I take money, give you money? The system works very well. So we would like to do it, of course, but the system works, and the customer says, okay, if it works, it's okay. 8.3, yes. Unbelievable, but it works. Also in Germany. Because in production they have to save money, they spend in the administration department. Is it different in Russia? Is it different in Russia that the production has to save money in order that the administration department can spend it? You know this? Okay. Any more question? Thank you very much.